All right. So we are going to eventually learn a lot about writing piecewise functions, which is when you have a function that is multiple different pieces. But the most simple piecewise function are absolute value functions, which are the functions we're studying right now because you could break them apart into two halves, the left half and the right half, and then write it as two different pieces instead of writing it as one piece. So we're going to start with this for this unit because it's a great way to introduce piecewise functions. And then when we get into our unit on functions and we introduce like other piecewise functions, at least you'll have seen more simple examples first and hopefully not feel quite so confused on them. So we're starting off with just the very typical absolute value function, which you guys know has a vertex at 0, 0. The vertex of the absolute value function is important because that's kind of the middle. That's what splits it in half, which for us is going to be what splits our piecewise function and makes us switch between the two pieces. And then on the right side, it goes 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. So that's going to be the right piece. We're going to make that the second piece of the piecewise function. On the left side, it's negative 1, 1, negative 2, 2, negative 3, 3, negative 4, 4, negative 5, 5. Okay, so for us to write each of these individual pieces down, we're going to think of this as a perfectly straight line, y equals mx plus b. So if I think about the left piece, this left piece has a y-intercept of 0, and it has a slope of negative 1. It goes down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. So I'm going to go ahead and write this piecewise function out. I'm going to say y equals, and for the left side, I'm going to say the slope is negative 1 over 1x plus 0. There's the left piece. And for the right piece, I'm going to say it has a y-intercept again of 0, and the slope is up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. That's the second piece. Up 1, right 1, x plus 0. So there's my two pieces, and this is how we write a piecewise function. We just say y equals, and then we tell whoever's reading our paper, hey, look at these two different pieces. Now, we can't just say two functions. We have to tell the person looking at our paper, look at the left piece, look at the right piece. And the way that we do that is we say if x is to the left of a certain value, if x is to the right of a certain value. And this is where the vertex comes into play. The vertex is going to tell you what value to look to the left of and to the right of. So here, the vertex is at 0, so you're going to say if you're looking to the left of 0, if you're looking to the right of 0. Now, 0 is not getting skipped. It's being included. There's no hole there. It's not a blank value. I'm not looking at this like, oh, there's a big gap missing from my graph right there. It's something that should be included. And so the way that I keep that value on the piecewise function is I just go through and I underline either this one or I underline that one, but I don't underline both. I just underline one or the other. Okay, it doesn't matter which one. And then at that point, I'm done. Now, most people would not do 1 over 1 for that value because that's silly. It's just negative 1, or it's even just negative x. And most people would not even put the plus 0 because it's 0. So most people would write this piecewise function as y equals negative x if x is less than or equal to 0, and positive x if x is greater than 0. And that would be their resulting piecewise function. So if you were to graph absolute value of x on a graph, and then you were to go to plug in this piecewise function, like you did this is y1 on a graphing calculator and this is y2 on a graphing calculator, it would actually graph the exact same thing. They would look exactly the same. They're exactly the same function. Ms. Rice, why are we making it complicated? Because when you get further along in math, you can't work with this anymore. We only work with this. So they start you off a little bit easier, and then once they get to the point where you are a little bit more mathematically advanced, we switch over to piecewise functions because, believe it or not, they're actually easier to work with. All right, let's do the next one. So now that we know about transformations, we can say, okay, -2 means I'm taking this one, I'm flipping it over, and I'm multiplying each of these coordinates by -2. So instead of going up 1, up 1, up 1, it's going to go down by 2 each time. So the vertex is exactly in the same spot. And then instead of going over 1, up 1, over 1, up 1, it's going to go over 1, down 2, over 1, down 2. So this is what our absolute value graph is going to look like. Okay. All right, so let's go ahead and write this piecewise function down. So for the left side, we have y equals, let's write the vertex. Vertex is 0, 0. Okay. The slope on the left side this time is a +2. So we have up 2 over 1, up 2 over 1, but we still have the y-intercept of 0. So I've got 2 over 1x plus 0. Okay. For the right side, it goes down 2 over 1, down 2 over 1, but we have that y-intercept of 0. Okay, and we're still saying if x is to the left of 0, if x is to the right of 0. Okay, and we're not skipping that 0 value, we're still going to include it, so I'm just going to put a little equal to right here. Okay, now I'm going to clean it up a little bit. Positive 2x. If x is less than 0, negative 2x if x is greater than 0. Okay, there's my piecewise function. Right. Okay, with this one, my vertex is +5, +1. Why did I make this one so it would be so hard to fit on this graph? That is a good question. Okay, and then it has a vertical stretch of 3. So instead of going over 1, up 1, it's going to go over 1, up 3. 1, 2, 3. 1, 2. I guess it barely doesn't fit on the graph, so that's kind of nice. Now, this one is like not even close to being able to figure out what the y-intercept is for either of those lines, and I'm not even going to try to draw it out and figure it out, but I'm going to show you guys a little trick to being able to do this. Okay, so the negative version goes first. The negative version goes with the left arrow. So even this one, see how it had a negative slope? So the negative version of the -2 gave you a positive here. I'm going to say that again. It had a -2 to start with. So the negative version of -2 gave us a +2 right here. So the negative version goes with the left arrow. And I did the negative version of a -2 and I got a positive, and that went with the left arrow. And then the positive version goes with the right arrow. So the positive version, even though this original problem was negative, so that's technically the positive version because I didn't change the sign. So the positive version goes with the right arrow. Write this down. All right. So we're going to do the negative version. And this is going to be the left arrow. And then we're going to do the positive version. And this is going to be the right arrow. Okay? Negative version, left arrow, positive version, right arrow. Negative version, left arrow, positive version, right arrow. Okay? Now, the number that goes over here always comes from the x value, right? It says if x is left of this number, if x is right of this number. This is the x number that we're splitting in half. Left side, right side. We're splitting the v in half at the x coordinate of the vertex. If x is to the left of 5, if x is to the right of 5. It doesn't matter which one you pick. Choose one of them, put an equal sign. So I'm going to take this, and I'm going to say this goes over here. Maybe make your arrow make a little bit more sense than mine did. Okay. And now I'm going to go ahead and clean this up a little bit. So I've got negative 3x plus 15 plus 1. Negative 3x plus 16 if x is less than or equal to 5. Okay, and then I've got 3x minus 15 plus 1. So that's 3x minus 14 if x is greater than 5. And there is the cleaned up version of my answer. All right, that was a lot all at once, so let's do another example like that. This one's good because it actually starts with a negative. Okay, so we're going to find the vertex first. So the vertex is negative 1, negative 3. Left 1, down 3. Why do I keep choosing these that barely fit on the graph? Okay, so it's upside down. It has a stretch of 2. So instead of being over 1, down 1, over 1, down 1, it's going to be over 1, down 2. There's your stretch of 2. It barely fits. Okay. So the first thing we're going to do is the negative version of the problem. So negative of negative 2, x plus 1 minus 3, and this is going with the left arrow. Then we do the regular version of the problem, or the positive version of the problem. So I'm not adding a negative sign, I'm just leaving it like it is, and I'm doing the right arrow. So first version, I add a negative, I use the left arrow. Next version, I keep the regular version of it and a right arrow. Then I think about what split this into the left side and the right side. The x value that split it between the left side and the right side is the vertex, and it's the x coordinate of the vertex. It's negative 1. That's what split it between the left side and the right side. Negative 1 to the left of negative 1 to the right of negative 1. It does not matter which one you put the equal to with. I'll put it down here. And then we go through and we clean it up. So minus minus makes a plus. I'll distribute the 2. 2x plus 2 minus 3. Negative 2x minus 2 minus 3. And there is my answer. I'm going to leave the other two examples for us to do in class, so don't worry about those other two examples for homework.